फिशन प्रोडक्ट्स जो हैं ज़्यादातर जब यूरेनियम स्प्लिट होता है इन न्यूक्लियर रिएक्टर, तो मोस्ट ऑफ द फिशन प्रोडक्ट्स आर प्रोड्यूस्ड and usually those fission products belongs to 1 2 3 4 fifth period. Most of the fission products belong to the fifth period, and these are strontium and its daughter is strontium is a fission product. Yttrium is usually its daughter. Zirconium, niobium, molybdenum is produced, and technetium is the daughter product of molybdenum, and then ruthenium may be directly produced or usually through the technetium. Platinum, tin, antimony, tellurium, iodine, xenon, okay, and the selenium, and this is usually fifth. Most of these are from the fifth period. So this implies a certain order that whenever the uranium is splitted, it produces most of the fifth group fission products. There are some other fission products like selenium, bromine or krypton, or the cesium, okay, or barium. These are also produced. The barium and cesium are from sixth period, but mostly are from fifth period, and the cesium and barium is the adjacent period. So the fifth or the sixth period, usually the fifth period is the dominant in the production of the fission products, whereas the other transuranic or actinide lanthanides which are produced, these are usually the neptunium, plutonium, americium, and curium. These are the actinides that are produced from uranium-238, because U-238 is the dominant part of the nuclear fuel, because usually the uranium is enriched up to 3.5%. So the rest of the 96.5% is the uranium-238. So uranium-238 is converted into the plutonium or the neptunium, okay, americium, mercurium. So these are the addition products that are produced from during the nuclear reactions. So these are actually the heat producing and long-term radiotoxicity causing elements. Among the fission products, cesium and strontium are also the heat producing, and they are the half-life is little bit higher. And other than the strontium and cesium, iodine is one of the radionuclide of the iodine is also the long-standing from the radioactive waste perspective. Apart from these fission products, the tritium is also produced from the lithium that is used in the nuclear reactor for the nuclear reactor chemistry to maintain the nuclear chemistry, as well as it's also produced from the absorbers or the boron shim that is used to maintain the criticality or to absorb the unwanted neutron during and then the reactor control. So that's also tritium is also one of the critical radionuclide that is produced. So it's almost whole periodic table, and the range of periodic table, whole range of periodic table is covered. That's why it's a little bit complicated, and it need to be studied. It was to be studied. What are the fission products from the inorganic chemistry perspective? Because usually the chemist in the journal chemistry research laboratories in the universities, usually it's not studies, and it is suppose that these fission products are fission products. Actually these are the elements, or this is the job of the chemist to understand these things in depth analysis, or in the certain labs have started their under independent work in China or in the USA, but mostly these are linked to the nuclear industry. But the chemist should come forward, and they should also study these things from the fundamental studies perspective. And I hope this direction or this drive will lead to the in-depth view or the new studies, new research about these fission products. That is the job of the chemist. Thank you.